So we focused the guidance on several common project scenarios. And then, as I mentioned, the guidance itself is 100 pages or so, and then the appendices are quite a bit longer than that. So we broke it up so that, again, folks could go to the part that they need to go to. So things are in the appendices like groundwater protection criteria, sizing calculation methods, and how to do infiltration testing, things like that. We've put stuff into what we hope are simple tables and thresholds where possible. So a little later I'll talk about TUDIA, so you guys keep that on your minds. I'll tell you what it stands for. And then we break out separate appendices in some cases on some issues for the North Orange County and the South Orange County permits. So again, Don showed this. The role of the document is to really get down to the how. How do I show what's feasible or not feasible and get to a decision about what I'm able to do at the site. Again, informing folks that are using the template and the model WQMP. So an example here, someone might start with a template. You're preparing a project and you need to document a site description. So you go to the template for that. And then you would then go to the model WQMP section 2.3 to see what is required, and then finally the technical guidance document section 2.3, and find the guidance on how to assess or what you need to do. So again, we've tried to line up some of even the section numbers on things to make them easier for folks to use. So I mentioned earlier the main document's a little over 100 pages. It gives guidance on how to develop a plan that complies with the permit, on how to complete the WQMP template, and then the appendices is about 260 pages and very modularized, again, on some of the either subject areas or in some cases differentiating between the North and Orange County permit. And we don't expect, unless somebody's got a big giant project with a whole bunch of different things going on, somebody's not going to have to be accessing the whole guidance document. So how this thing is organized, there's an intro section that just goes over the document. We then have section 2 is kind of the main section for how to prepare a WQMP. Again, I mentioned it mirrors the WQMP template, and then there's subheadings in there for all the different things that you have to do to prepare the template. So there's information and guidance on how to do the site and watershed characterizations. The site characterization, one of the things you got to think about is how to break up the site to do the analyses, because there might be parts of a site where you can infiltrate and part that you can't. Good example there might be if I've got one little part of the site that has some below ground soil contamination issues that are going to remain in place as part of whatever remediation or strategy there was, and so i.e. not a good idea to infiltrate on top of that, but there might be other parts of the site where you can. There's a selection flow chart, there's feasibility criteria and worksheets, guidance on then how to demonstrate that you've conformed with the requirements of the permit for sizing and selection of VMPs, and we looked at a bunch of scenarios. And then also separately from that, there's guidance on incorporating US EPA green streets into WQMPs. So there's a flow chart. This is a simplified flow chart here of how one would look at it. But first you could go through and say, is my project fully retaining? Meaning, the green roof example I gave you is one. If it is fully retaining, you could be done at that point, at least for that portion of the site. If it's not, can you do infiltration or rainwater harvesting? How much? If it's not all feasible, can you biotreat? And essentially getting down to you're complying with the permit. So I forgot I had it billed here, but I've pretty much been through it. So some of the scenarios you might have is the project is able to feasibly retain the design volume. The project, or another one might be they can't fully meet the design volume but can biotreat the remaining, or can't feasibly retain and cannot biotreat, or the project can't feasibly retain the entire design volume, and there's not any feasible retention BMPs. So those are various different kinds of scenarios that one could get into. So section 3 gives site design principles and techniques. So some things, it's actually going to be a lot of the things that you're familiar with in some of the previous WQMPs and things like that. We've tried to minimize the overlap with section 4. So the bottom line is your previous permit did have some LID type things to think about in there, or things that you should look at. And so those are primarily included in section 3. And then 4 gets into the detail of LID and how to actually design to meet the treatment volume, and selecting BMPs that address the pollutants of concern, and then performance tables. So some examples, this is the categories of BMPs, and then section 4 covers hydrologic source controls, so things like street trees or other kinds of things like that I mentioned, infiltration systems, harvest and use, evapotranspiration, which there's obviously some overlap between the hydrologic source control section and the ET section. And then biotreatment, and we were pretty broad about how we defined biotreatment, so it includes things like the natural treatment system type facilities for wetland treatment systems and things like that, as well as bioretention and filtering through soils and media. And then we have the more traditional treatment controls, things like sand filters, cartridge filters, and then some pre-treatment type BMPs. And in the guidance we give information on how effective those BMPs might be at different pollutant types. So if I was in a watershed that had heavy metals as a part of my TMDL, I'd probably want to be selecting BMPs in here that get the H and maybe an M if I'm for medium, so high, medium, and low. So again, we provide some guidance there for selection of BMP types. Section 5 gets into the HydroMod side of things, and gives guidance on how to do the hydromodification calculations, and then the processes for the North and the South Orange County. And then section 6 discusses all the source control measures. Again, this should be pretty familiar for the most part from previous permits. And then section 7 provides guidance on operations and maintenance kinds of things. So developing agreements and what are the appropriate maintenance activities for each of the BMP types. So now I'll run through each of the appendices. There's a gazillion of them. The first one is for summarizing the sizing requirements for the North Orange County. The second one does the South Orange County. So again, it gives guidance on selection and sizing for various project scenarios. There's some cheat sheet kinds of things in there to help folks. And the same kind of guidance is provided in Appendix 2 for South County. For Appendix 3 gives the hydrologic methods for calculations for sizing of LID BMPs. It provides, again, worksheets and examples, guidance, and then describes the basis for the percent capture criterion. So this is one of the details that we had to get into, is we wanted BMPs that actually are effective, despite what the permit says, is almost the way I'd phrase it. And so we wanted to make sure people were actually going to select BMPs that treated, the target was 80% of the runoff from the site. So again, that's what that's about. And you could, for example, if you put in some kind of system that took 5 days to drain down, you're just not going to treat 80% of the runoff anymore, because that system will be full a lot of the times when the next storm event comes along. So again, that's what that issue gets into. And then, so just some examples here as it provides sort of instructions for folks to go through, calculation worksheets, and then some examples in how to use some of the charts and figures that we have in here. So the issue I mentioned earlier, if I was going to design something that drained down, so essentially a lot of these BMPs work by having a storage volume and then a rate that I can get rid of the water some way after it's been treated or managed appropriately. So say if I had a bioretention system that would drain down over 96 hours, I can use charts like this to, so I go to the 96-hour level, I can use charts like this that would tell me how much of the, how big would I have to design the facility to actually treat 80% of the runoff. Appendix 4 gives approved methods for quantifying the hydrologic conditions of concern. This is, again, primarily for the HydroMod site, and this was for the North Orange County. Appendix 5 then gets into the same information for the South Orange County. There's a big difference between the requirements for the North and the South right now, particularly for the interim requirements. I think as the WIMPs and whatever the name is for the South Orange County hydromodification plans go forward, we'll probably start to see more commonality between the two sets of requirements. But for right now, the ones in the South Orange County are quite a bit more strict based upon the permit requirement for the interim controls. Appendix 6 has methods for calculating alternative compliance volumes for LID. So this gets into essentially alternative compliance calculations. And most folks would only need the worksheet here that's provided. And this is stuff that we'll get into a lot more detail on in the next upcoming training session, so I'm not going to spend a lot of time on it. And then Appendix 7 gives infiltration evaluation protocols. So if someone's going to choose infiltration, we want to make sure it's going to work. And so we've put together an appendix that goes through different kinds of testing procedures. This is a double ring infiltrometer, it's called, that one can use to look at infiltration rates on a site. And this gives guidance about safety factors and all the rest of it in terms of determining whether it's feasible and to infiltrate and how much. So again, there's lots of worksheets in there to fill in and guidance there. This is probably one of the better synopsises of really looking at infiltration feasibility out there in the United States, as far as I know. You know, there's bits and pieces of it in other manuals. The other thing we worked really hard with the Orange County Water District on is, given that some of the areas where you can infiltrate, the best infiltration is also areas that would infiltrate into aquifers that the Orange County Water District is managing or using. We wanted to make sure we looked at a whole bunch of issues, some of which are important to them and some of it's just geotechnical issues too, but things like groundwater mounding, plumes, you know, where do we have septic systems and making sure we don't mess with those, the contamination risks, either soil contamination or plumes, and then you know, how to consult with applicable groundwater agencies. So I had that little jokey cartoon earlier, but in reality, this is a big issue for the water district. So, you know, in that guidance, there's maps showing the plume areas and locations of, you know, dry cleaners and all those kinds of things. There's guidance on mounding issues, so we don't want too much mounding to go on, which could cause foundation issues in buildings and things like that. So there's a little summary table of the feasibility criteria. Appendix 9 provides a technical basis on the green roof side of things. So if one chooses to do a green roof, one can look at that. Now green roofs aren't considered to be a mandatory consideration, and this is one of the things where there was quite a bit of discussion on with some of the environmental community. There's harvest and use demand calculations, and this is a tricky one because again, you know, a lot of the general theory out there in the stormwater world is, oh, well, you just put a tank in and you capture this water and you use it to irrigate, and we save potable water and we eliminate runoff. Well, you really have to you have to drain the tank fast enough to actually make that system work from a stormwater perspective, and so you need to have a good amount of stuff to irrigate.
Eric, at one point, Vector Control wanted a 48-hour drawdown, or maybe it was 72.
Yeah, I think it's 72 to 96 hours is what they're looking for.
Okay, so do we have a hard cutoff? In other words, are we able to say if you can't do it in 72 hours, it's infeasible?
I think for any of the surface systems we do, I'm going to have to go look up the numbers. Probably 72 or 96 hours. It's one of those two. But, you know, if you had an underground cistern and you have the ability to, I mean, there are methods to keep stuff from getting into those systems, then that may not be quite as applicable, right? Like the cisterns at Pelican Hills are actually designed to draw down over 10 days, right? But there's things in place there to keep mosquitoes from getting in there and doing their thing.
Well, if it's a sealed system, in theory, you could keep it there for months.
Correct. Right, right. So I'm just saying it's probably more of the issue is surface storage systems or systems where, you know, mosquitoes have access to.
I mean, there's some of the trade-offs, you know. If you have a surface infiltration basin or similar,
Yeah.
it's going to take up more footprint. You need to drain it down in the 7 to 6 hours. But it's going to be potentially, you know, first cost per gallon base.
Yeah.
You go down below ground with some kind of cistern or other similar kinds of these infiltration, well, you know, it actually saves lot footprint, more buildable lot. You don't then have the limitation on vector control. You still have to drain it in time so that it captures some of it.
Yeah.
So there's trade-offs, but they're more complicated than they may not look.
Yeah, the Pelican Hills project, the tanks were put underground. The one picture I showed you, there's actually a water quality basin on top of the tank. So the tanks collect the first amount of runoff, and then they're actually treating runoff over and above what fills up the tank in a dry extended detention basin built on top of the tank. So there was they chose to do a multiple use, but both water quality as well.